Okay, this is an augmentation video of the animation I did previously where I created sight lines within the concave LSE Earth, and I showed how the pole stars work at different latitudes within the Earth. This animation, I created intermediary sight lines to help you understand how they are intersecting the celestial sphere, as well as giving you a point of reference, or I created this little eye in this apparent dome that we apparently see in the sky, but actually because of the bending of the light and the optical inversion that takes place, it's not really a dome in the sky, it's actually the opposite. It's a sphere in the middle of the Earth. And so, let's stop this animation. I'll just demonstrate or describe what's going on here. Pull this up in After Effects. We see, as I scrub across the timeline, where I have this apparent sun within this apparent dome. And so the apparent sun is traversing across this blue line here, which is the 23.4 degrees north solstice. So this is during the solstice time. And so we see how the sun moves like that, and from our vantage point in the center there, wherever we look at the sun, we're always looking at the front of the sun. And so that's the masterful divine illusion that takes place there, where the bending of the light is causing us to always view the front of the sun, the front of the moon, front of the planets, and it creates an opposition in curvature. So we're at 45 degrees north here in Michigan, time of the solstice, and if we turn around and we look at the celestial sphere, obviously we see the inversion. We see the intermediary sight lines that are all intersecting the celestial sphere perpendicularly, and then we see the sun here at the bottom here. We see this blue line, which is indicating the time of the solstice at 23.4 degrees north. We see the equinox blue line here a little bit lower, and we notice that it's an opposition in curvature. And then we also see the sun over here, and it's flaring out just like that, but we also see these sight lines that they're parallel with the back rays of the sun. Behind the sun, like I told you before, it's only a half of a sphere, and it has these parallel collimated light rays that are hitting the back of it. So we're never able to see that from Earth's vantage point because of this bending of the light. And so we see how they're wherever the sun is traversing across these sight lines, they're parallel to the lines behind the sun. See that? So that is why we're only able to see the front of the sun. It gives us the illusion that there's just this apparent dome to the sky. Here's another animation I did, or demonstration. I can show you what's going on here. I put this eyeball in the middle here. Okay, and so I'm creating this. Let's tilt it up like that. There we go. I have this mock sun within this apparent dome, and there's, like I said, it's not a real dome above us. It's a sphere, but the inversion of the curvature creates the opposite effect. But wherever the sun goes within this apparent dome, the eye is always going to see the front side of it. So that's what's happening. The eye is always looking at the front of the sun, the front of the moon. Okay? Ooh. So going back, I'll play the animation again. And so wherever you are, whatever latitude you are, you're always going to see the front of the sun because of the bending of the light rays like that. And they're all intersecting the celestial sphere, as I said before, perpendicularly. So I can go back, I can show you in the modeler here how I created these intermediary sight lines. You notice how they're, whatever angle they're at, they're always hitting the celestial sphere perpendicularly. Okay, so this would be the zenith. There's no bending of light when you're looking straight at the zenith point. But if you angle your eye toward the horizon, obviously the most extreme, that's when you're looking at the horizon. So you're actually looking straight across here, but Your eyesight is carrying it up like that, and it's creating the inversion. We see an inverted sun and an inverted moon at the horizon. It's upside down. Proof of that is when you see the moon illusion. If you look upside down between your legs, that illusion is going to go away. That's proof that the moon is upside down at the horizon. So that's what's going on. Okay. Thanks for watching.